2.1. In section 2.1, we are going to start talking about functions. Okay, so a function is a relation in which each element in the domain is paired with exactly one element in the range. So you see here, like the -3 points to just one other number. 0 points to just one number. And so in math, you know this from geometry, that word exactly, it has a precise meaning. When you say exactly one, you mean just that. One, not 0, not 2, 1. Okay? So one element in the domain is paired with exactly one element in the range. Okay, fine. But what is domain and range, right? Domain is the set of all of the x values that exists for a function. In other words, it's the independent variable. So if you have, an x and a y axis, the domain would go here. It's all of the x values that exist, and this is the independent variable. Okay, the range is the set of all of the y values, and it's called the dependent variable. So all of the y values that exist for a function is the range, and these are the values in the dependent variable. Okay? Now, with domain and range, you have to express values always in ascending order, increasing order, right? And in our honors, like in an honors class, besides content, we also need to be correct with form and notation and everything. Okay, so let's take a look at this. We need to determine the domain and the range for each function, and then determine whether each is a function. Okay, so let's see. So here, for the domain, so first of all, values of a domain are put in these curly brackets. So what I do is I take all of the x values, okay, and I'm going to put them in increasing order. So it's going to be -4, -3, 0, 1, and 3. For the range, right, the y values, so I have -2, I have two -2s. Don't write them twice, just write them once. 1, 2, 3. Cool? Now, is this a function? Yes, it is, because each x value has one y value. Another way of saying that is, do any of the x values repeat? No. So, yeah, but that's okay. That's okay. So it's a function because none of the x's repeat. Okay, so here the domain is going to be -2, -1, 1, and 2. Yeah, it has to be the curly brackets. It can't be anything else. What's the range for this one? Right, -1, 0, and 1. Don't repeat the numbers in the range or the domain. Just write them once in ascending order. Is this a function? No. No, it's not a function because, right, the -2 repeats. Right? So, yeah. So you would normally just write yes or no. Okay. So here, what's the domain? Wait, -3, -2, 3, and 4? Yeah. And then what's the range? -5, -2, 5. Is this a function? Yes. Okay, what about here? What's the domain? -6, -3, 0. What's the range? What do you guys think? 0, 1, and 3. Function or no? No, not a function because the zeros repeat, right? Okay. So if you have your relation presented in one of these forms, like coordinate points, table, graph, or, coordinate points again, you can use this to see if it's a function. If you have the graph, though, there is another way to test for a function. That is the vertical line test. So here's what the vertical line test is. If you have the graph of something, you can draw a series of, they're imaginary lines. You can draw a series of imaginary vertical lines. If each line crosses the graph at only one point, it's a function. But, so here, no matter what, where you draw the line, it's one time. But if it crosses more than one time, then it's not a function. Okay? That also means, like, for one x, like if x is 1, it has 2 y's. Do you see that? It repeats. It's 1, 2, 1, negative 2. Right? Yeah. Okay. So let's take a look at this. Graph. So it says graphing calculator, but we're not going to use the graphing calculator just yet. Because, so it says graph, determine the domain and range, and state whether it's a function. Now take a look at A. We should all know what the graph of that looks like. Yeah? Okay. So what does it look like? Right. So if this is -5, then we go up 1 over 2 there, right? Now, okay. Now we got to figure out domain and range. So for domain and range, another way of looking at it is, how much of the space does this graph take up? Okay, so domain is horizontal. Horizontally, how much of the graph does this take up? How much of the space does this graph take up? So it's going to expand on both sides, right? It's the whole thing, so it's all real numbers. What about for the range? It's vertically. Vertically, how much of the space does it take up? Also all real numbers. Okay? No. Let's take a look at D. Okay, let's take a look at D because that's another one we should be able to do, like, just by looking at it, right? X equals 2. What does the graph of that look like? A straight line, horizontal or vertical? Vertical. So look. So this is x equals 1, x equals 2. This looks like this. Okay? So, okay. So let's do domain and let's do range. Okay, domain. Horizontally, how much of the space does this take up? Just one dot at where? At 2. So the domain is just 2. Vertically, how much of the space does it take up? All of it, so it's all real numbers. Okay, going back to A, is that a function? Yes. Yes, because it passes the vertical line test, right? So yes, it's a function. Let's go back to D. Is that a function? No. Okay. Because if you draw a vertical line through the blue line, how many points does it pass through? Infinite, right? Like if you draw a vertical line, it passes through so many points. 1 for the vertical line test. 1. Okay.
So
yeah.
a function has to be like perfectly linear.
No, because this isn't linear, but it passes the vertical line test. Yeah. Yeah. Okay. Now, what does this look like? It's a parabola. Okay, this one, why don't we put it on our calculator? So go ahead and take out your calculator. I'm going to show you. Now, I'll talk about the quiz later, but let's do this now. Okay, press the on button here. Yeah. Top right, on button. Now, To get a calculator screen, you're gonna press, do you see this button with like, it's like the speedy calculator? If you press it once, you get a workspace. If you press it again, you get a graph. Okay, here, we're gonna type in x squared. Okay, the variables x, y, z are at the very, very, very bottom row, grayed out, or in gray. X.
Yeah, I don't have that.
Okay, press tab. Tab is right above the blue button. Do you see it now? So x is at the very bottom, squared left of 4, plus 4, press enter. Got it? Okay. Okay, now, let's talk about domain and range. What's the domain? Horizontally, how much of the space is this going to take up? Is that right? All of it? Yeah, because it's going to expand. So domain is all reals. How about range? What about 4?
Because it's going to take up. No, 4. 4, yeah, 4.
Yeah, it starts at 4 and goes up. Okay, now is domain the x's or the y's? I'm sorry. Wait, stop. Is the range x's or the y's? Y's. So for the range, we're going to say y is greater than or equal to 4. Is this a function? Yes. Passes the vertical line test. Now, one way to clear is press the dock button, right side, second one down. And then in the alphabet keypad, press the letter B, so dock B. Now, press the calculator button again and then get that F1. Let's type in x cubed minus 1. Okay, so type in x. For the cube, you have to go farthest left from the 4 to the power of 3. But now when you do power of, you're up in the exponents. You have to exit out of the exponents by pressing the right arrow, minus 1. Okay. Okay. What's the domain? Is that right? All real numbers?
Yes.
Yes. Yes. What's the range? Also all real numbers. So domain, all real numbers. Range, all real numbers. Is this a function? Yes, it is. Okay, fabulous. So now, go ahead and put away your calculators. Now look, okay, so listen, this is important. Your quiz on Thursday will be no calculator, which means, so ones like this and like this, you know how to do them without a calculator. If I give you ones like the other ones, I will like give you the picture of the graph, okay? Okay. Now, discrete versus continuous relations. A discrete relation is like this, where you just have points on a graph, not connected. Continuous is when you have a smooth curve or line. How many points exist on that continuous relation? Infinite amount. Okay? Okay. Now that we're talking about functions, let's talk about function notation. So if you have an equation, 3x minus 1, to write it as a function, the y gets replaced by f of x. So this would be f of x instead of the y. So now, suppose you have an equation of a line, And in function notation, it's this, right? Now, you are asked, what is f of negative 6? Okay, so if you look at f of x versus f of negative 6, what's changed? X became a what? Negative 6. So inside the function, you're asking, what is the y value when x is negative 6, right? That's what we're asking. So if I have f of negative 6, then instead of x, I substitute negative 6. So it becomes 2 times negative 6 minus 3. So that's negative 12 minus 3, negative 15, right? So that's f of negative 6. Cool? And you can see here, if this looks familiar, it's because you did it in Algebra 1, right? Like on the board, I have some stuff from my Algebra 1 class that just left. Okay, so here I have f of x and g of x, and I need to find these. So first, f of negative 2, 2 times negative 2 squared minus 3 times negative 2 plus 1. Okay, do you notice how because the negative 2 is a negative, I put it in parentheses? Please do that, right? Because then the negatives just go awry. So that's 2 times 4 plus 6 plus 1. What is that? 8, 15. Okay, f of 3a, 2 times 3a squared minus 3 times 3a plus 1. So this is 2 times, what do I get when I do 3a squared? 9a squared minus 18a plus 1. 18a squared minus 18a plus 1. Oh no, that's 9a. What? Oh my God. Jacob, you said 18 and I wrote down 18 before. You said it for the other one, but my brain copied it down for this one. Okay, and then you, like, this one doesn't factor, but even if it did, you wouldn't factor. You just leave it this way. Yeah. Okay, g of negative a half. Okay, now we're going to use the g function. So this is 5 over negative a half plus 2. How much is negative a half plus 2 these days? 3 halves, 3 over 2. So that's 5 times 2 thirds, 10 thirds. Yep.
How come when you square 3a, it's 9a squared?
Because the 2, the square, since it's in parentheses, it belongs to both of these. It belongs to the a and the 3. So it's 3 squared, a squared, 9a squared.
Oh, because the a is not really a squared.
Yeah. Okay, next one. Next one. F of b minus 3. Okay, this is a good one. So let's just write it down. Go ahead. So I'm going to put b minus 3 instead of the x. Okay, I normally, when I'm grading the quizzes for this section, I normally have to take off way too many points, way more points than I would like for ones like this. So let's just like make sure we get it right now, okay? Here, I have 2 times. Now I need to do this. B minus 3 quantity squared. What's that going to be? Okay. Now, let's see what that is. I'm just going to work like on a scratch paper here, okay? B minus 3 squared is like b minus 3, right? So now if I like FOIL, b squared minus 3b minus 3b plus 9. So this is b squared minus 6b plus 9. Yeah? But this is like so algebra 1, right? There's a formula we could do. Here's the formula. B minus 3 squared, right? Okay. You square the first one, b squared. You square the last one, plus 9. Then you do b times negative 3. How much is that? Negative 3b times 2, negative 6b, right? b times 3 times 2, 6b. So here we go. So regardless, this is going to be b squared minus 6b plus 9. Distribute this. Plus 1. Distribute the 2. Okay. Minus 3b plus 10. 2b squared minus 15b plus 28. Did I do that correctly? Mm-hmm. Yay. Okay? All right. How does that sound? Good? Yeah. Okay, next one. Here I have 2 times g of a. 2 times, what's g of a? Right, so what would it be? Right, so what's g of x? It's 5 over x plus 2, so this will be 5 over a plus 2 over 1, 10 over a plus 2. Okay, so here we go. G of a half. Okay, we did g of negative half before, so this is 5 over 1/2 plus 2. 5 over, what is this? 5 over 2. 5 times 2/5. Oh, isn't that cute? That's a 2. Cute, huh? Okay. Okay, the next one is a different problem. Next one, it's not saying g of a number. We're not changing x. It's still g of x. It's saying, what if g of x is 3/4? What is x? What is the given g of x here? This. Now this is saying that is equal to 3/4. Exactly. Okay? So this will be 20. You cross multiply, equal to 3x plus 2, right? So 20 equals 3x plus 6. 14 equals 3x. 14 over 3 is x. Questions? Okay, so that's section 1. Now we're going to do section 2. Section 2 is just a page, and it's like so quick. I don't even know why it gets its own lesson. Okay, so linear functions. You guys already know linear functions. Over here, which one of these were linear functions? A is a linear function because you get a line when you graph. Okay, so here we go. Yeah. Okay, so linear relations give you graphs with straight lines. Now, how can you tell if the function is linear, right? Well, If it's a linear equation, it cannot have powers other than 1, square roots of variables, variables in the denominator, or products in the variables. So look, all of these are linear equations, right, Elias? All of these. Okay, sit up. Here, the first one. Why is the first one not linear? Because it's y squared. Okay, Ian, why is the second one not linear? It's the square root. Okay. Akiva, what about the third one? Right, x and y are being multiplied. Maya, what about the fourth one? Because there is a variable in the denominator. Okay? Okay, so here we go. So we have to decide whether each of these are linear. Okay? Okay, so Elias, what about the first one? Is it linear? Yes. Okay. Okay, Luke, what about the second one? Is it linear? B. B is not linear. Okay. Who else? Liam, what about C? Yes. Lila, D? No. E, not. F, definitely not. Okay. So here's the big one. This is super important. And actually, you know what? This one, I'm going to change this one to 24. Can you guys change it to 24? Because then it doesn't work out nicely. It's just boring if it's a 4. 24 is more exciting. Yeah. Okay, so listen. If you have a function or a graph, right? This is the x-intercept. At that point, what's the value of the y? 0. This is the y-intercept. What's the value of the x? 0. Yeah. So here, let's find the x-intercept. We're going to make y 0. We're going to plug in 0 for y. So this becomes negative 8x plus 12 over 3 equals 0 plus 24. Right? Huh? I mean, I don't know. Should we do this one together? No. Huh? You want to do it on your own? Okay, do it. I'll race you to it. How about that? You ready? Wait, what? Huh? 2, 1, go! Go! Okay, what'd you get? Negative 12. Is that what I got? Anybody get something else? What did you get? What is that? Simplify. 15 over 2? 15 over 2.
Yeah, I'm not gonna lie. I had it where it was 8x equals 60, but I just guessed it was 12.
Okay, we'll get another one. We'll get another chance later. Now, the way you're going to write this is this. This is the x-intercept. Negative 15 over 2, 0. Okay. For the y-intercept, we're going to make x 0. So let's do that. So it's going to be 0 plus 12 over 3, 16y plus 24. Okay, on your mark, let's go. We'll race. Okay. Okay. How do we write this?
0,
Okay, so this is y equals that, right? So it goes in the y spot. This is x equals in the x spot. Okay, so this is how we find x and y intercept. All right, let's do the other one.
What are we doing for y or x? What are we doing for y or x?
First, x intercept. Let's do x intercept. All right, I'm going to race you guys. On your mark, get set, go.
X equals 12.
Okay. So 12 comma 0. Okay, so for this one, for the y-intercept, we're going to make x equals 0. So y equals 1 over 3 times 0 minus 4. Y equals negative 4. Now, if you put in your answer space y equals negative 4, not full credit. Because if it's an intercept, it has to be in intercept form, in coordinate form. Okay? Isn't that cool? So there we go. So the homework is a worksheet. I'll distribute in class, but it's also on MyJag. All right? Okay. So